What if closing your laptop didn't kill your coding agents? Diri just went open source. I read through it and then I set it up. Here is what the architecture actually looks like and exactly how I would wire it on day one. On August 4th, 2026, Diri dropped its source under Apache 2.0. The next day, v0.4.1 landed as a universal, signed, and notarized macOS DMG. Apple Silicon and Intel, Gatekeeper clean out of the box. Automated self-updates come via an appcast JSON feed. Homebrew cast support is in there too. None of that is glamorous. All of it tells you someone has thought about operational reality rather than just shipping a demo. I went through the repo before recording this, and a few things jumped out. First, the commit history shows this is not a weekend project dressed up with a license file. The offset address session logs in the daemon suggest someone has thought about replay and crash recovery, not just keeping a process alive. Second, the MCP injection surface is genuinely novel, but also the part I would scrutinize hardest before trusting it with anything metered. And third, the Tailscale integration in diri-node is the kind of pragmatic networking choice that ages well. No custom tunnel logic, just a listener on an existing mesh. The thing I kept coming back to is that the two-process split is the right call for this class of tool, and I want to explain why before we get to setup. Diri runs as two separate processes, a Rust and GPUI front end, the desktop window, and a headless Swift daemon running independently. The daemon owns the PTY masters, the offset address session logs, and the control socket. The front end is a view layer that connects to the daemon. When you close the app, or when the UI crashes, the daemon keeps running. Your agents keep running. This is the TMUX mental model applied to a coding agent orchestrator. PTY detachment is not a nice-to-have when you are running a dozen parallel agents across Git worktrees overnight. It is the difference between a tool you can trust and one you have to babysit. The feature that raises the most interesting questions is MCP injection. Diri injects a model context protocol server directly into each agent environment. That means an agent can programmatically spawn and orchestrate child agents. You are no longer the only one deciding when to scale horizontally. The agent can decide. That is a real shift in the orchestration model. The open question, and it is a real one, is what guardrails exist inside the diri-node usage ledger to prevent a runaway loop from exhausting your API budget. The usage.scale Lite 3 ledger is there. The brief does not specify hard budget caps or circuit breakers. That is the first thing I would audit in the source before pointing this at anything production. Diri-node turns any VPS into a first-party remote execution host over a Tailscale listener. Enrollment tokens and account profiles handle identity. Handoff operations, move and fork, let you migrate or duplicate a running session across hosts. The usage.scale3 ledger gives you a local audit trail of what ran where. For a solo developer or a small team running agents across a few cloud boxes, this is a genuinely useful primitive. For a team with compliance requirements, you will want to confirm what that SQLite ledger actually captures before you rely on it for audit obligations. The sourced shortlist here is two tools. Conductor is the closest peer, also a macOS desktop UI layer for parallel coding agents across Git worktrees, with cloud micro VM support and multiplayer workspace sharing. The key difference the brief surfaces is Diri's two-process daemon architecture, giving you PTY persistence that a purely UI-centric tool does not guarantee. Whether Conductor has equivalent daemon resilience is not something I can confirm from the sources in front of me. Intent from Augment Code is a different animal. Enterprise-grade, spec-driven, with a context engine indexing over 400,000 files for semantic analysis. Diri is not competing with intent on context depth. It is competing on orchestration resilience and remote fleet reach. Beyond those two, sourced third-party head-to-heads are thin, so I am not going to invent a broader shortlist. Here is the specific sequence I would run. Step 1. Install via Homebrew Cask so your machine setup scripts stay clean and the auto-update feed handles future versions without manual intervention. Step 2. Before you run a single agent, open the source and find the usage. Light 3 schema. Run a schema query against it. Understand what the ledger captures. That is your cost surface and your audit surface, and most people will skip this. Step 3. Start with one Git work tree and one agent. Confirm that closing the desktop app leaves the daemon process running. Verify the session log persists. That is your trust but verify moment for the two-process claim. Step 4. Only after that baseline works, wire up diri-node on a single VPS over Tailscale. Use an enrollment token, run a handoff fork operation, and confirm the session migrates cleanly. Step 5. MCP injection is last. Enable it in a sandboxed environment with a low API budget ceiling set at the provider level, not inside Diri at the provider, until you have confirmed the self-spawning behavior stays bounded. That ordering matters. The daemon resilience is the foundation. Everything else sits on top of it. If you are on Mac OS running parallel coding agents and you have lost work because closing your laptop killed a session, clone the repo this week. The Apache 2.0 license means the floor for experimentation is low. If you are evaluating orchestration tools for a team, put Diri on the watch list. The MCP self-spawning is architecturally interesting, but the budget guardrail question needs an answer before you hand it a production API key. If you are on Windows or Linux, the GPUI frontend is macOS only right now. The brief notes ActiveEngine worktree commits suggesting a port is in progress, but there is no confirmed timeline. Wait, Diri is an indie open source project with a genuinely thoughtful architecture. The two-process daemon model, PTY persistence, and MCP injection are design decisions you can read in the source, and you should before you run it. The day one sequence I walk through is the order I would actually follow. Ledger schema first, daemon resilience second, remote fleet third, MCP last. Apache 2.0 means the experimentation cost is low. The ceiling depends on whether the budget guardrail and cross-platform questions get answered. Repo link and the landscape comparison are in the description.